Good morning, everyone, and thank you for joining us for today's presentation on Windows Server 2008 and about how we've reached end of support and what you should do. My name is Scott Houghton, and I'm here with Mayor from Amazon. Mayor?
Thanks, Scott. Hello, everyone. My name is Mayur Dwaiker. I'm a product manager at AWS. I work on the Elastic Compute Services team focusing on Windows workloads. I've been in the tech industry for about 17 years in various roles, including engineering, product management, and technical sales. Some of my prior roles were at companies such as Commvault, Pure Storage, and Symantec. So I think, Scott, you're going to be doing your introduction, so take it away.
Yeah, I'm Scott Houghton. I'm a senior cloud consultant here at Mission. I've been working on AWS for a little over 10 years now. Remember a lot of changes over the years. And I've been working with Windows Server pretty much every version since NT4, so I've seen a lot of different migrations. And been in IT a long time. I had my first certifications when I was 16. And I'm a Navy veteran. So, like I said, I'm with Mission, and Mission Cloud Services is a leading AWS premier consultant. We have offices in Los Angeles and Boston. We specialize in architecture, migration, management, and optimization. So we can definitely help with your complete strategy when it comes to these type of migrations.
So a quick introduction on Windows on AWS before we get into today's presentation. So I thought I'll just give you guys a little bit of history on the Windows workloads on AWS. So Windows workloads have been on AWS longer than most of the other cloud providers combined. So today, we've been running Windows workloads for over 10 years. We have a lot of experience running Windows workloads. We've been delivering a lot of innovation around Windows-related workloads for the last 10 years. AWS, as you know, has global reach. We are in several geographies around the world. Today, we're in over 60 zones, availability zones, and roughly 22 geographic regions. We have over 50 security and compliance certifications, which include most of the standard industry certifications that you would run into out there. We have over 100 services that we offer as part of our portfolio. We have EC2 instances that can deliver up to 80,000 IOPS per instance with significant consistency. And over the last 14 years or so, we have dropped prices over 70 times. So as you know, Amazon has a general principle that we want to be able to drop prices whenever we can so that we can pass down those price drops to our customers so that they can get the most out of their investments on AWS. So we've been following that principle over the last 14 years, and we have dropped prices over 70 times. So in today's session, what we're basically focused on is the end of support event that just happened last month around Windows 2008. There are a lot of customers that are still using legacy versions of Windows. So in a study that was conducted by a market research firm, showed that about 40% of the workloads are still running on legacy versions of Windows, so either 2008 or 2003 or even 2000. So there's a lot of workloads out there, and there's a lot of resistance amongst our customers to move to a newer version of Windows. So we'll talk about what some of those challenges are that are preventing people from move, and then we will talk about the end of support migration program that we recently launched at our annual conference reInvent back in December. So we're going to be talking about this program, how it works, and then we're going to have our friends at Mission talk a little bit about their expertise around Windows workloads, and then we'll end the presentation with a small demo of the technology around end of server migration program, and then we'll open up the lines for some Q&A. So let's dive into the presentation. Let's start by talking about what end of support means for enterprise customers. So when you're running end of support operating system, you have significant security exposure because the operating system provider is not able to provide you the latest security updates, and with all the security attacks that we hear of, there is a significant security risk that you are exposing yourselves to when you have a operating system that is end of support. Most of the customers are required to run a currently supported version of the operating system to meet with industry regulations such as HIPAA, SOC, or any other regulations that your specific industry may be subjected to. So that compliance problem is front and center for a lot of customers when it comes to end of support operating systems. Also, when you are running end of support operating systems and applications, you have to typically run this in an isolated setup, and you have to pay the provider extended support costs, which can run into several $1,000s per instance. And so there is a cost element associated with running end of support applications as well. And then finally, most of the cloud providers are required to pull down the instances of end of support operating systems, which means if you're trying to migrate these workloads over to cloud, you are most likely going to be out of options. So the true way to really resolve these kind of issues is to figure out a way to get the operating system upgraded and get the applications moved over to the new version of Windows so that you are able to address these particular problems that come up with running end of support operating systems in your environment. So then that begs the question, why are people not acting? What are some of the challenges that we typically run into? The first one is around lost expertise, lost media very frequently. So some of these applications are so old that the customers don't have expertise sitting around anymore in terms of their the personnel. The code may be really old. Also, they may not have installation media sitting around. The second problem is when you have to refactor or recode these applications for a new version of Windows, that requires significant cost and time commitment. And if the application is not something that is impacting the business right away, the motivation to go through that exercise is pretty low. The third risk is around upgrades. So upgrades, if they fail and you end up in a soup where you're not able to get the application moved over, then you find yourself in a downtime kind of situation. So there is a risk associated with that. There's also a lot of applications which are just not compatible with new versions of Windows because these were custom, off-the-shelf applications that are not available on new version of Windows. So that could be another risk associated with moving to a new version of Windows. And then finally, some of these dependencies that these applications have with runtimes like Java and .NET are just not available in the new version of Windows. So if there were a specific version of the runtime that the application was calling upon, that just may not be available on the new version of Windows. So there might be an incompatibility issue which requires you to simply go through the refactoring and recoding effort to make sure that the application can run on the new version of Windows. So that is where we basically identified a lot of pain points as we were talking to customers. And at Amazon, we take a very customer-centric view to solving problems. And when this was starting to come up as a repeated concern with end of support, we decided that we needed to really solve this problem with tooling and also service that we can offer, which allows customers to get the applications upgraded to a new version of Windows without requiring any kind of recoding and the replatforming. So that's what led to the creation of the end of support migration program for Windows Server. So end of support migration program is a offering from AWS, which it consists of the technology, the tooling that is required to get the application upgraded, and also the expertise directly from AWS, our ProServe resources, or our partners such as Mission, who have a lot of expertise in Windows and also around EMP to help our customers get their applications upgraded once and for all. So the EMP program is basically, it consists of tools and expert help from us or our partners, and the typical EMP engagement goes through a three-step process. So in the first step, when we engage with our customers, we look at what application is the customer looking to upgrade. We look at what kind of dependencies the application has in the environment. So we go through this process called application assessment, where we do a discovery of the application. We define the testing criteria with the customer in terms of what they would like to test when the application actually gets upgraded over to a new version of Windows. So that's the first step, really kind of setting the stage for a successful deployment. In the second step, we do compatibility packaging. So we take the application and we package it up using our EMP compatibility tool, and we package it up with all the underlying dependencies. So any application calls that are going down to the operating system level, any dependencies that are required for that application to run, we basically package that up in a package that will then be moved over to a new version of Windows. So I have a demo here in this presentation that I'll show you to basically illustrate exactly how this process works. But basically we're packaging the application, all its underlying dependencies. If for some reason the customer doesn't have access to the media for the application, we have an option to do reverse packaging. So the reverse packaging is done from a production environment. We basically let the tool run and monitor the application and all the underlying dependencies that it has. And then we capture all of that in a package, and then the package basically is moved over to a new version of Windows. So we can do regular packaging if we have the media sitting around. If we don't have the media sitting around, we can do reverse packaging from a production version of the application itself. Now, once the package is created, we can take the package, move it over to a new version of Windows, such as 2016 or 2019, and then the package and the Windows instance with that package running on it is basically moved over to an instance of AWS, right? So an EC2 Windows instance on AWS is where that package gets moved over. So that's just a regular migration, and that can be accomplished using tools such as Server Migration Service, short SMS, and also Cloud Endure, which is the other tool we have in our portfolio to do server and application level migration for on-premise workloads. So a little bit more details on the EMP packaging itself. So we have the legacy application, here you see where we call it the source, and then the underlying operating system. And then the target is basically showing you the legacy application running in the package itself. And then what we're basically doing is we're taking all the underlying dependencies that I mentioned, and then we're packaging that in the application. So that application with the underlying dependencies runs in a self-contained package, which is running on the new version of Windows. So what we're basically doing is we're creating a redirection process, which basically intercepts any Windows API calls that are required for the application. Those API calls are served directly from within the package, because most of the times those API calls are calling like legacy Windows dependencies. So those are all packaged in the package that we created. So those are all being served from that local instance in that package. We also are running things in an isolation. So the older version of the runtimes can only be accessed by the packaged application. So we don't create any kind of a security risk in the rest of the organization. So that application isolation is super critical, and we do that as part of the packaging process. And then as part of the packaging, we are also resolving any OS incompatibilities that we might run into, and then we are basically resolving those directly from within the package itself. So why should someone use EMP, right? So EMP is a permanent solution to a end of support problem. With some of our competitors, they will allow you the option of simply extending support on the legacy version of Windows. And then what will happen is you're basically kicking the can down the road. So you might buy extended support today, which will serve you for the next 2 to 3 years. But when you run out of the support, extended support, you basically have that exact same problem again of what do you do with that end of support application that you have running on EOS version of Windows. So EMP is future-proofing your applications because we are decoupling the application from the underlying OS dependencies. It allows you to basically get latest version of the security updates because your application, once it's packaged, runs on a new version of Windows. So it reduces your security exposure. It allows you to then be compliant with the industry regulations that you might be subjected to because the application at that point is running within that packaged container in a new version of Windows. And then you don't have to pay extended support, so it becomes a super cost-effective way to run your application. So you don't have to and then do any kind of application refactoring or recoding, which is a really big advantage of our technology here with EMP. So the question that often comes up is, so how expensive is this EMP application in terms of resource overhead? And to be super candid about the overhead in terms of resources, this application is super lightweight. So in all the testing we have done thus far, the overall CPU hit is less than 1%. We're using roughly 10 megs of additional disk space to run the package itself. The RAM overhead is super minimum. We're not installing any agent or client, and there is no additional infrastructure that's required to run this application. So it's a really lightweight packaging that we do as part of this EMP tooling. And so the overhead for the customer is going to be basically non-existent. So they won't even realize that the application is running in a package on their EC2 instance when it moves over to AWS. So we've had this tool and this technology now for a few months. We've had some success with our customers. So we have National Australia Bank, Origin Energy, and another customer named Inmarsat that have gone through the pilot that we were running right around the launch time, and they have upgraded applications to a new version of Windows and successfully moved them over to AWS. So we have some case studies that we're working on with these customers, and they're also available for any reference calls that the customers might be interested in should they decide to move forward with the technology. So with that, I'm going to be doing a quick demo of our technology here, and we will be doing a roughly 2-minute video. So let me share my screen here. Okay, so with what I have here in this demo is a SQL Server 2000 running on Windows Server 2008. So it's a legacy version of Windows Server, and the SQL Server is even older, so it's SQL Server 2000. So what we are trying to do here is we are trying to basically move this over to a new version of Windows. So what we will start by showing you is that this SQL 2000 version is basically incompatible with a 2019 version. So when we try to basically run this on a 2019 version, it's basically incompatible, right? So let's try running this on 2019 by clicking on the exe file. When we do that, we're basically told that the app cannot run on your application, right? So on your operating system. So at that point, we're going to basically install the EMP tooling. With the EMP tooling, we are able to get the application set up. With the application set up ready, so this is the EMP tool that we have. We have to then basically do a snapshot of the instance. And what we're doing is we're basically doing a snapshot before the application is installed, and then we do a snapshot after the application gets installed. So basically then do a diff against the two versions to see what is happening in the setup. So we'll start by creating a folder where we can put the package for this packaging exercise. So we start the capture of the application, so we're capturing the before, and then once the capturing is done, we will do the installation of the application. So in this case, we have the SQL 2000 media sitting around, so we are going to basically do an install, and we are going to then capture all the dependencies that the application has as it installs in this package itself. So we're going to run the 2000 application, SQL Server 2000, and this is being done basically on a 2003 version where this application actually works. And then we are basically, once the application installs, we have all the shortcuts set up. And then what we do then is we do a capture of the setup once again after the application is installed. So what we see here is files which are captured in the package, files that are required in the runtime, and then we have the option of basically capturing whatever is required, including the registry keys, to create the package itself. So now we have created the package in its entirety, and what we're doing then is we're basically moving the package over to a new version of Windows. So this is 2019. So once the application and the package itself is moved over to a new version of Windows, we're basically ready to do the application install at that point. So the application is being installed. Once the application is installed, you'll start to see all the shortcuts on 2019. And then we will also do a quick connection test here to make sure that the application is ready. So we're just running a test to an instance of SQL here to make sure that the setup is set up correctly, right? So we just ran the test here just to show you that the SQL 2000 version got migrated over to Windows 2019 after we did the packaging on the server offline, and then the application was moved over to 2019, and then it was installed within the package, and then we ran a quick test to show that it actually works. So that was the quick demo of the technology. We are able to do in-depth demos. We are also doing a free POC at this point in time. And we can, if you reach out to Mission or you reach out to your AWS representatives, we can get you into the free POC program that we are currently running for our customers to demonstrate the technology. So with that, I'm going to hand it over to Scott to continue the presentation. So Scott, take it away.
Thanks, Mayor. So I'm going to go ahead and highlight some of the benefits of Mission Cloud and our expertise with Windows workloads, specifically Windows migration to AWS. We're going to look at a couple case studies from Microsearch Corporation and ATCC. So the Microsearch Corporation came to Mission Cloud. They're a digital services company that specializes in providing custom video and document search engine services for clients across the U.S. When they approached Mission, they had aging hardware on-premise and servers running older versions of Microsoft Windows and Microsoft SQL Server. Now, through our experience, we were able to consolidate those 36 on-premise servers down to 24 cloud EC2 servers, so providing some cost savings there and lower maintenance. And we were also enabled Windows and other Microsoft applications to be able to function optimally in the cloud and on AWS. And even better, we were able to leverage virtual desktop infrastructure for end users to be able to access sensitive applications and data such as QuickBooks. We were able to provide this all with secure VPN access for all the employees. Now, accelerating deployment and reducing migration costs was definitely a big highlight here, and a big thing we were able to provide to them. We were able to eliminate projected CapEx costs, about $100,000 what it would have cost to refresh their on-premise data center, and we were able to cut their ongoing monthly cloud costs by 80%. So some considerable savings there for MicroSearch. Let's take a look at ATCC here. So this is another customer we had at Mission. ATCC maintains the largest and most diverse collection of biological materials in the world. After years of using the same provider to host its servers, ATCC unexpectedly found itself with just weeks to migrate to its entire Windows-based environment of 8 terabytes of data just before the data center's host was about to shut down. So it's definitely not a good situation to be in. So leveraging Cloud and Door, Mission proceeded to successfully migrate ATCC's entire Windows environment to AWS Cloud in just one day, well ahead of the data center shutdown closure deadline. So this just definitely demonstrates how well we can migrate in very short deadlines. We were able to set up a cross-regional disaster recovery environment in AWS, also using Cloud and Door. And ATCC experienced no unexpected downtimes or issues during this very complex migration. So this just kind of highlights some of the benefits of using Cloud and Door for some of these migrations, and just the benefits here we have at Mission and the experience we have with this type of infrastructure. I'm going to put up some questions from the audience.
Yeah, so the question is, how long does the EMP process take? So the EMP process typically, depending on the complexity of the application, can take anywhere from 1 day to 1 week. And the majority of the time is being spent in discovering the application dependencies, making sure that we have the right mapping captured, and that we are able to capture everything in the package successfully for the packaging to be complete, and then for us to start the testing process. So again, depends on the complexity of the application, but it could take anywhere from a day to about a week. The second question is around looking ahead, what other EOS announcements should Windows-based companies be aware of? So EOS for 2008 just happened in January of 2020. There are still a lot of workloads. In fact, we know for a fact, just having looked at even our own install base, there's a lot of workloads that are still running on 2008, 2003. So right now, the immediate call to action is to talk to AWS or talk to your partners about what would be the best way to get these applications moved over to a new version of Windows and then moved over to AWS as part of that process. And another pertinent event that's going to come up in about 2 years is going to be the end of support announcement for 2012. So I typically like to tell the customers I talk to start planning for it at least a year in advance. So it gives you enough time to look at what you have in the setup, decide what's super critical to get moved over, and then really put a plan in place to move the applications over to a new version of Windows. So for the 2022 deadline for 2012, you should typically start planning for it sometime in 2021. So that just gives you enough time to do the planning. So those are the two events, the 2008 EOS that just happened, and then the 2012 that will happen in 2022.
Okay, let's do a last round. Any more questions? All right. So let's cover the next steps if you want to learn more or get in touch with AWS and Mission. So if you want to be able to future-proof your Windows applications, you can visit Amazon's website, aws.amazon.com/EMP TAC Windows Server for more information, or you can request a consultation with Mission. And make sure to follow Mission and AWS on LinkedIn for more updates and on upcoming webinars. And that's all we have today, folks. Thank you for joining us.